Hi, I'm Catherine Hayhoe, and these are the answers to the questions that I received when I gave a presentation at the Environmental and Water Resources Institute, which is the Austin chapter of the American Society of Civil Engineers. There was a lot of great questions. I'm going to answer the top 6. Here we go. Question number 1. How do we manage water conservation with a city's need to see water? Well, they probably didn't mean this literally. A lot of places do get their water from surface reservoirs, so they can literally see it with their eyes, but many places also get their water from groundwater, underground reservoirs, aquifers, which you can't actually literally see. But the real question is, how do we manage water conservation when for most people it's just a matter of turning on the tap and out comes the water? I think it's not an engineering question and it's not a scientific question either. It's a question of communication, of having conversations with the people at the city who make the decisions, who need to understand where our water comes from. How have those water sources changed in the past? How do we expect them to continue to change in the future? Are we concerned about long-term climate trends or changes in variability that might impact the supply of water from these resources? Is there anything that we can do to hold off these declines? Are there things that we can do to diversify our water supply? Or do we really have to look hard at the hidden source of water, which of course is water conservation? Communication, talking about where our water comes from and how it's changing, I think is key to getting water conservation on a city's agenda. Question number 2. The state, meaning Texas, does not incorporate climate information into its water planning. How can we ensure political subdivisions push for this information when deciding on regional water allocations or plans? This is a really good question. It is true that the state does not account for the impacts of a changing climate, either the long-term trends or the changes in variability in their plan, but a lot of water districts do, both districts and cities themselves. So all across Texas, there are cities and districts that are already accounting for these changes, because as we talked about, if you don't do it, it's kind of like driving down one of our dead straight West Texas roads, just looking in the rearview mirror, depending on the past as a guide to the future. This works great if the road is straight, because where you were in the past is a perfect guide to the future. But when you hit a giant curve in the road, if you're looking backwards, you are not going to end up where you plan to be. So we talked about how planning for the future based on the past is like driving down the road looking in the rearview mirror. Unfortunately, this is what the state is doing by failing to incorporate climate projections into its long-term planning. It's making a decision that is not fully informed by all the available science and data. And one of the strongest arguments, I think, for changing that is to bring to the table examples of how these have already changed in the past, not looking to the future, just the past, and how using this information has helped to make cities' water plans and districts' water plans more resilient. But jumping ahead a little bit to question 5, question 5 actually also relates to this question. Question 5 asks, does politics change your data? Well, politics definitely doesn't change data. A thermometer isn't Democrat or Republican. It doesn't give you a different answer depending on how you vote. But unfortunately, we live in a world where the number one predictor today of whether people agree climate is changing and humans are responsible and we need to take that into account in our decisions is not how much we know about the science, how much access we have to data and facts. It is simply where we fall on the political spectrum. So politics does not change the data that scientists provide, but unfortunately, this data is misrepresented and manipulated for political reasons. And I'm going to give you a couple of examples of that and also show you a resource that you can go to if you have any additional questions. So here we go. Here is fake example number 1. Don't tell anyone, it says, but we just had 2 years of record-breaking global cooling. What's the truth? Well, they're citing NASA here. So if we go to NASA's website, which actually tracks global temperature around the world since the 1800s, this is what NASA's website has. You can see that temperature goes up and down from year to year, But long term, it is going up and up. And you can see that the only thing that was unusual about the last 2 years here, as indicated by the green arrow there on the right, the only thing that was unusual about them is that they would have been the two hottest years on record if it wasn't for the preceding two hottest years on record. So they're not record-breaking global cooling. The last 4 years were, in fact, the four warmest years on record. And as we talked about, of course, you have to also understand the difference between weather and climate. Weather is what happens in a certain place at a certain time. So a single year is weather, it's like a tree. But climate is the long-term average of weather over at least 20 to 30 years. So when we're looking at global temperature over climate timescales, we can't look at the difference between one year and the next. We have to look at what's happening over longer time frames. Here's another, maybe a bit trickier example of fake. This is a figure that claims that the physics-based models that we use to study the climate system have massively overestimated the warming, and in fact, reality, the real warming, has been tiny. Now, the first clue here is that this is not a very sciencey looking figure, but the second clue here is in the sources. Let's take a look at the sources here. The sources are listed as various, as described in the State of the Climate in 2012 in the Bulletin of the American Meteorological Society. So this is a legitimate journal, and the State of the Climate report is certainly in it. But if you go to that report, you will not find anything that looks like this. Absolutely nothing. But if you want to see what scientists have, this is an actual scientific figure with real data. What we have here in black is the observed global temperature. What we have in the orange is the range of model projections. And you can see the fact that there was no range on the left is another clue that there was something going on, because climate scientists always work with a range. We don't work with any single value from a model. What do you see here too? You see that the data sources are explicitly listed. There is uncertainty included. The source is also listed, and it's based on a figure that was originally designed by the Intergovernmental Panel on Climate Change. So you can actually track down and recreate this data, which shows that actually the models track the observations very well. But if you try to track down the data that they use for the figure on the left, you're going to have a few problems. If you see anything else that seems like it might be fake or it might have been altered for political reasons, one of the best resources I recommend is skepticalscience.com. They have listed over 200 common objections that people have to climate science, and they've listed them in order of how frequently they occur. And if you click on each one of these arguments, it will take you to a page where it tells you all of the data. It links directly to the original scientific studies, and you can go as deep as you want to actually figure out what is going on. Our Global Weirding series on YouTube also addresses a lot of frequently asked questions. So our most recent episodes talk about how climate change affects different regions around the US, but we also address very common questions like, so the world is warming, but it's only a few degrees, who cares? Or why does climate change matter to Texas? Or isn't it just a natural cycle like El Nino? We have videos about all of these too, so please check out globalweirdingseries.com. So question number 5, does politics change your data? No, but does politics change data to make it look different? The answer, unfortunately, to that is yes. That's why it's always good to make sure that you get the information that you need from a scientist, and you get the full source information too, so that if you want to check where it came from, you can do that. But back to our list, question number 3. How is groundwater storage changing, and how is that connected to climate change? Well, the most important reason why groundwater storage is changing, especially here in Texas, but throughout the South Central region and actually largely around the world, is withdrawals. We are taking the water out of the underground resources and aquifers, and that is the number one reason why groundwater supplies are dwindling. But that doesn't mean that these trends are not exacerbated or amplified by a changing climate. They can be. How? At least 3 ways. First of all, the warmer it is, the faster evaporation happens. So when there is rain and moisture at the surface, if it's warmer, more of that water evaporates rather than trickling down to recharge the aquifers. The second thing is that we are also seeing that heavier rainfall is becoming more frequent. So what that means is you get more surface runoff, you get faster replenishment of surface water supplies, but that means that that's not actually going into groundwater. So the trend towards increasing heavy precipitation can actually lead to decreases in recharge as well. And then third, if you're in an area where the overall precipitation is decreasing, that would also have an impact on groundwater resources also. Question number 4. Are we too late to reverse current trends? This is a great question, and we actually address this specifically in the chapter that I wrote for the U.S. National Climate Assessment. So the chapter I wrote is chapter number 4, and the first key finding is this. Some amount of change is inevitable because of what we've already put up into the atmosphere. It's kind of as if you've been smoking a pack of cigarettes a day for not just years, but decades. Some damage is inevitable, but the worst hasn't happened yet, so we still have a chance to make a difference. So key finding number 1 says, if heat trapping gas levels, greenhouse gas concentrations, if levels of heat trapping gases in the atmosphere were stabilized at their current level, we would still be committed to an additional 1 degree Fahrenheit or 0.6 degrees Celsius of warming over this century. But key finding number 3 says, beyond the next few decades, how much climate change we are going to see depends on what? Depends on the choices that we make that will determine our emissions of heat-trapping gases. Our choices have a huge impact on our future. We also have a global weirding episode on this, and in it I talk more about how some amount of impacts are inevitable. They're already here today or they're coming soon. But the biggest uncertainty in the future is our decisions. By acting now, we can avoid the most serious and even dangerous impacts of a changing climate. But we have to act now because by the time they happen, it's too late. It's as if you're, being put into the ambulance on the way to the hospital after you just had a heart attack. And you say, no, don't take me to the hospital. I promise I'll eat properly and I'll exercise now. That doesn't work. The time to do that was 10 years ago. It's the same with climate change. Question number 6. What is the single most important thing that an individual can do to help mitigate climate change? This is a fantastic question because as a climate scientist, when I first started talking to people about climate change, I was really good at talking science, diagnosing the problem, telling people how bad it was, telling people how our choices really do make a difference. And then people would say, well, like what choices? And I'd be thinking, well, we all know the stereotypical answers, change a light bulb, recycle, but that's not very satisfying. And we know instinctively that that is not going to fix a problem this big. So then I thought, well, this is what we need to do. My next answer was step on the carbon scales. If we're going to lose weight, the first thing we do is step on the scales to see how much we weigh and set a goal. There's carbon footprint calculators. This is only one. There's many of them online, where you can actually measure your personal and your family's carbon footprint. You can figure out where your emissions come from, and a good carbon footprint calculator will tell you also what are some things that you could do to reduce your carbon footprint. So I did this, and I found that there were a lot of actions that I could do. Yes, I absolutely could replace my light bulbs. Even the fancy looking ones come in LED versions these days. I could also recycle. Here at Texas Tech, we actually run the recycling program for the city. Our housing department has opened the recycling program to the public, and they recycle everything, including old clothes and styrofoam and more. Eating local and eating lower down the food chain and not wasting food is really important. Food waste is a huge source of heat-trapping gas emissions. Transportation of food, like kiwis from New Zealand, apples from Chile, has a huge carbon footprint, and especially beef and also pork has a much higher carbon footprint associated with it than eating lower down the food chain. Don't have to run out and get a new car right away, but when you do, you might consider getting a car that is a hybrid or that is very fuel efficient or that's a plug-in. This is the type of plug-in I have. It doesn't have the hugest battery in the world, but it has enough battery to get me to school and back and run my errands around town. And then this past Christmas, my husband actually got us all, as a surprise, solar panels for our roof so we could actually charge the car and everything else from the solar panels. But when I stepped on the carbon scales, though, the biggest part of my carbon footprint was not how I transport myself. It was not how we heat and cool our home. It was not what I eat. It was not how we wash our clothes. It was not the light bulbs that we have. The biggest part of my carbon footprint was, if you can guess, this is an interview that I did for the World Economic Forum, and at the bottom it says the first thing she did might surprise you. The biggest part of my personal carbon footprint was flying. Ironically, flying around to do research on and study and talk about climate change. So what I decided I had to do was transition a lot of my talks to virtual talks, like the one that I gave today. So now I give about 75% of my talks virtually, which are very low carbon. And then when I do travel places, I try to gather all of my invitations together. I'm going to Washington, D.C. next week, and I have non-stop events where I'm either speaking or having meetings all the way from 9 a.m. to 9 p.m. for 2 straight days in a row. So the carbon footprint of each individual event is actually going to be pretty low. But even this is not entirely satisfying, because we know that we need more. We as humans, as individual people, we only control about 30% of the decisions that determine our carbon emissions. And even there, we can't even necessarily make the decisions we want to. I mean, I would love to have a fully electric car, but there's no public charging stations. I think the closest one is Amarillo. So I can't drive to Amarillo every time I get stuck or drive home. Sometimes we can't even make the choices we want to. And that's why it's so important to not only look at the choices we can make in our life, but to advocate for societal action. One of my favorite resources here is called Project Drawdown. You can find it online at drawdown.org. They rank 100 different solutions to climate change, and along with the wind turbines and the solar panels, you also find some really interesting ones like biochar. The idea of burning agricultural residue at very high temperature and then putting it back into the soil, where it's like Miracle-Gro on steroids. Putting carbon in the soil is actually a good thing. It fertilizes the soil. Clean cook stove projects in poor countries is a really important way to reduce deaths from indoor air pollution, to reduce people cutting down trees and deforestation, and also to reduce net heat trapping gas emissions from that deforestation. I love that number 6 is educating women and girls in poor countries to reduce infant mortality rates and to enable women to support their families. And then number 3 might be kind of surprising. Remember, I mentioned food waste earlier. If food waste were its own country, it would be number 3 after China and the United States for the most heat-trapping gases produced. Food waste. We throw away a third of the food we produce. So there's some really fascinating societal-wide choices. But the most important thing we can do individually, I have come to realize, is none of the above. The most important thing that we can do is tackle the biggest things that we don't think are true and that we're not doing. What are those? Well, if you look at public opinion polling, this is a really interesting set of maps from the Yale Program on Climate Communication. They have data for each county and each congressional district across the US, and you can go there and you can actually zoom in on your location. So when they ask people across the US, do you think global warming is happening? It turns out just about everybody does. Okay, everybody thinks it's happening. Then do you think it will harm plants and animals? Most people say absolutely yes. Do you think it will harm future generations? People say largely yes. Do you think it will affect people in developing countries? It's a little bit bluer now. Blue means less than 50%, orange means more than 50%, but it's still pretty orange. Do you think it will harm people in the US? Yeah, probably. Now we get to the kicker. Do you think it will harm you? No. Just about nobody, no matter whether they agree with the science or not, thinks it will affect them. And even worse, when they ask people, do you ever talk about it? You know what the answer was? No. So that's why when Ted came calling last summer, not a person called Ted, but like the TED Talk Ted. And they said, "What do you want to talk about if you give a TED Talk?" I said, "I want to talk about what I have realized is the most important thing we can do about a changing climate, and that is talk about it. Because if we never talk about it, why would we care? If we don't care, why would we act?" So the single most important thing that anybody can do about a changing climate is talk about why it matters to us in the places where we live, and what are some sensible, sound solutions that can help us build resilience, adapt to the changes that we can't avoid, and avoid the changes that we can by transitioning off fossil fuels to clean energy. And that feeds right into the last question, which is, what is the single most critical message that needs to be communicated to community leaders regarding climate trends? The most important message I think that every single person needs to know is that we care about a changing climate not because of the polar bears, not because of future generations. We care about it because of us. A changing climate matters to us because it exacerbates so many of the risks that we already face today. And we talked about some of those risks. We talked about drought, we talked about hurricanes, we talked about heavy rainfall events, we talked about extreme heat. These are all normal and natural parts of life in Texas. But as the atmosphere warms, it's supercharging these events, making some of them stronger, others more frequent, and some of them both. Here in Texas, we already get more billion-dollar weather and climate disasters than any other state in the entire country, 104 since 1980. And what climate change is doing is it's loading the dice against us. Anywhere we live, we already have a chance of rolling a double six, an extreme heat wave, a flood, a drought. If you live in Texas, we already have 3 sixes on our dice naturally. But as climate changes decade by decade, it is sneaking in and replacing another and another and another of those numbers with sixes. And then we roll a double 7 one day. Our risks are going up, the weather dice are getting loaded against us, and this is a really important thing for us to understand in the places where we live, particularly here in Texas, because we are one of, if not the most vulnerable state in the country to these type of increasing risks. What does it look like when the dice are being loaded against us? Well, it looks like this. The monsoon in Southeast Asia is a normal and natural part of life there, but having a third of an entire country underwater is not. 500-year floods are a normal and natural part of life, maybe not everybody's life, but they happen. But having 3 500-year flood events in 3 years in Houston is not. We are seeing the weather dice being loaded against us in Nebraska, throughout the Midwest, in Indonesia. It's not just heavy rainfall. We're also seeing record-breaking droughts in South America, in Africa, in Southeast Asia and India, which is experiencing a massive heat wave actually right now, in Australia, in Europe. Wherever we look, we're seeing record-breaking events because normal and natural events are being supercharged by a changing climate. So the most important message, I think, when we do the most important thing we can, which is talk about it, the most important message is that the exact person we already are, the things that we already care about, makes us the perfect person to care about a changing climate. And if we care about water, even more so. Thank you.